Okay, so we're looking at exercise 8D from the second year Stats and Mechanics textbook, and this exercise is on differentiating vectors. So we've got quite a tricky question here. Bearing in mind this is the second year textbook, so they've given us some slightly trickier differentiating. So you might not have done much on this yet, but differentiating an exponential is actually quite straightforward. Okay, but so let's have a think. So actually, I don't need to differentiate for part A. So part A is asking me the time at which the particle is directly northeast of the origin. Okay, so they're asking me about its position. So as I said, I don't want to differentiate. I actually want to use the position vector. So let's have a think about what they're talking about. So if something is directly northeast of the origin, so north and east, so northeast is going to be in that direction there. So if it's somewhere along this line, if we think about it in terms of sort of x and y coordinates or I and j vectors, anywhere on that straight line, the I vector is going to equal the j vector, or the x coordinate will equal the y coordinate. Okay, so if I go back to my position vector, if I need it along that line, the I vector, which is going to be 5e to the minus 3t, must equal the j vector, so must equal 2. Okay, so now we've got to work with exponentials and natural logs to be able to solve this. Okay, so that's the interpretation of the question. That does come up quite a lot. So it's a tricky to start with, but hopefully if you think carefully about what they're saying there. So they said, when is it northeast? So there's sort of what they're talking about there. So if it's northeast, so that's 45 degrees and that's 45 degrees. So that's basically the line y equals x. So it's when the coefficient of the I vector equals the coefficient of the j vector. So I'm going to divide through by 5. I am going to take natural logs. I'm going to divide through by minus 3. And if I check back at the question, it doesn't mention exact values or anything like that. So as soon as you want to start putting that into your calculator, that's absolutely fine. Obviously, it would not make sense if I got a negative answer here. But actually, I'm not going to get a negative answer because ln of 2/5 is negative. So I've basically got a negative times a negative. And I am getting 0.30, and the standard rounding is 3 significant figures. They don't mention anything else, so 0.305 seconds is my answer for that. I'm just going to check that before we go on, because I need to check my working. Come on. Maybe I won't. There we go. Yep, okay, we're good. Right. Okay, so then they want the speed. So that's what we were expecting, because you're going to differentiate. So that's what this whole exercise is on. And we're going to differentiate the position vector to find the velocity. And I need to be careful that I notice that they've actually asked for speed. So we'll have to think about how that changes things. Okay, so velocity is going to be the differential of our position vector. So there's our position vector. So so this is sort of the slightly trickier bit of differentiating. And all that happens when you differentiate e, or a function of e, when it's of this form, the power is not going to change, and I'm going to multiply by the differential of that. So the differential of the minus 3t is minus 3. So I'm going to multiply, by minus 3, and I'm not going to change the power. So you're going to do a lot more practice of this in your second year core maths, but there's no harm in having a look at it now, and it is actually pretty straightforward. Okay, and then the 2j, so that's my I vector, and the 2j, the 2 is just going to differentiate to nothing. Okay, so my velocity is just going to be minus 15 e to the minus 3t. Okay, and they want the speed at this time. Okay, so this time is our previous answer. So when t is 0.305. So I've actually got that answer still on my calculator. So I could use the exact answer, or I could use my answer to 3 significant figures. So the velocity is minus 15 e to the minus 3 times 0.305. So times my t by that. Okay, so you should, if I've done that correctly, oh, okay, so you should get minus 6. So that's what I got when I used the exact answer for t. Okay, so effectively use that version there because I didn't clear my calculator. So if you use 0.305, you might get a slightly different answer. So what's the relevance? So that's the velocity vector. So what's the relevance of them asking for speed? Well, speed is just the magnitude of the velocity. So if there was an I and j component, I would be using Pythagoras, but there isn't. There's only an I component. So basically that means 6 meters per second in the negative I direction to the left. So if I didn't want to use Pythagoras, it would be 6 squared plus 0 squared, which is a bit of a waste of time. But as they've asked for speed, I would ignore the negative and the vector. Okay, so its velocity is minus 6 meters per second in the I direction. So that's going to be minus 6 meters per second to the left. But the speed is just the magnitude of that. And that would be worth a mark on the end. So it's always notice if they ask for speed rather than velocity. Okay, explain why the particle is always moving directly west. Well, so that's just a relatively straightforward interpretation. Why is it always moving west? Well, our velocity, so it's the velocity that sort of tells you the way it's moving, so the direction it's moving. And how do I know that's always west? Well, west is to the left. Okay, so it's always moving directly west for 2 reasons. One is the j component of the velocity is 0. So that tells me it's never moving north or south. So that tells me it's always moving perfectly horizontally. Now, how do I know it's always west? How do I know it's never going to be going off to the right? Well, that's because if I look back at this, e to the minus 3t, so if I ignore the minus 15, e to anything is always going to be positive. So if I'm multiplying that by minus 15, it will always be negative. So the I component will always be negative, which means it will always be going off to the left or in the west direction. Okay, so let's just clearly explain that. So that is always greater than 0. So if I multiply it by negative 15, it's therefore always less than 0. So let's just be clear about what we're actually saying there. Let's move it up a little bit. So the I component of V is always negative, therefore always travelling west. Okay, so it's a bit messy there, but gets the point across. Okay, so let's just check. Did I miss anything? I can yeah, so we're in slightly more detail than they did. Okay, so